number 8. So question 8 asks, how do you calculate the oxidation number of an element in a compound? So first let's write down the definition of an oxidation number. So oxidation number is the charge that that atom would have if the compound was composed of ions. So ion just means an atom with a charge. So I'm going to look at the Janine The Tutor's answer because they have all the different rules of how you would calculate the oxidation number. And then I'll just go over some examples. So here are some of the rules. The oxidation number of a free element is always 0. So if we had like a pure solid or a pure gas, it would have a 0 as its oxidation number. Oxidation number of a monatomic ion equals the charge of the ion. Oxidation number of hydrogen is +1, but it is -1 when combined with less electronegative elements. So if hydrogen was a hydride. Oxidation number of oxygen in compounds is usually -2, but it is -1 in peroxides. Oxidation number of a group 1 element in a compound is +1. Oxidation number of a group 2 element in a compound is +2. And same with group 3 elements as well. It's +3, but that's not there. The oxidation number of a group 17 element in a binary compound is -1. And the sum of the oxidation numbers of all the atoms in a neutral compound is 0, because your compound is neutral. And the sum of the oxidation numbers in a polyatomic ion is equal to the charge of the ion. Okay, so now that we know all of the rules, let's do some examples. Let's say we had aluminum sulfide, and we want to find the oxidation number of the sulfur atom. So this compound is neutral, so I'm going to write a 0. And then to try and solve for the oxidation numbers, since rule number 8 says the sum of all the oxidation numbers of all the atoms is 0 of a neutral compound, I'm going to do 0 is equal to 2 aluminum, since there are 2 atoms of aluminum, plus 3 sulfur, and then plus 12 oxygen. So in the brackets, I am now going to put in the oxidation number of each of the atoms. So aluminum is a group 3 element, and it has an oxidation number of +3. And rule number 4 says the oxidation number of oxygen is usually -2. So since this is not a peroxide, oxygen has an oxidation number of -2. So I'm just going to plug those values in. So there's 2 atoms of aluminum plus 3. Okay, that's clear. And we're looking for S. And it's going to be 12 times -2. So it's going to be 6 plus 3s minus 24. And now we just solve for s. So let's bring that over to this side. S is equal to plus 6. Okay, so the sulfur has an oxidation number of plus 6. I'm gonna do another example on the right side. So let's pretend that we had a charged compound, like a polyatomic ion. So for example, let's say we had H2PO4 minus. And we want to find the oxidation number of the phosphorus. So since this ion has an overall -1 charge on the left side of the equation, I'm going to do -1, because rule number 9 says that the sum of the oxidation numbers in a polyatomic ion is equal to the charge of the ion. So -1 is equal to 2 times the oxidation number of hydrogen, since there are 2 atoms of hydrogen, plus phosphorus, plus 4 times the oxidation number of oxygen. Okay, so let's recall that hydrogen, so this isn't a hydride, so each hydrogen atom has an oxidation number of +1, and each oxygen atom has an oxidation number of -2. So now let's just plug in those values. And then solve for the unknown. So we end up with an oxidation number of +5 for phosphorus. Okay, so those are just some examples of how you would calculate the oxidation number. And I'll just say for the junior tutor, this solution is correct. They gave all of the rules on how we would solve for it.